Immunological memory is long-lived after infection or vaccination. Most children in the United States are now vaccinated against measles virus. Before vaccination was widespread, most were naturally exposed to this virus and suffered from an acute, unpleasant, and potentially dangerous viral illness. Whether through vaccination or infection, children exposed to the virus acquire long-term protection from measles. The same is true of many other acute infectious diseases. This state of protection is a consequence of immunological memory. The basis of immunological memory has been hard to explore experimentally. Although the phenomenon was first recorded by the ancient Greeks and has been exploited routinely in vaccination programs for over 200 years, it is just now becoming clear that memory reflects a persistent population of specialized memory cells that is independent of the continued persistence of the original antigen that induced them. This mechanism of maintaining memory is consistent with the finding that only individuals who were themselves previously exposed to a given infectious agent are immune, and that memory is not dependent on repeated exposure to infection as a result of contacts with other infected individuals. This was established by observations made on remote island populations where a virus such as measles can cause an epidemic infecting all people living on the island at that time, after which the virus disappears for many years. On reintroduction from outside the island, the virus does not affect the original population, but causes disease in those people born since the first epidemic. This means that immunological memory need not be maintained by repeated exposure to infectious virus. Instead, it is most likely that memory is sustained by long-lived antigen-specific lymphocytes that were induced by the original exposure and that persist until a second encounter with the pathogen. It was thought that retained antigen bound in immune complexes on follicular dendritic cells might be crucial in maintaining these cells. But recent experiments suggest otherwise. While most of the memory cells are in a resting state, careful studies have shown that a small percentage are dividing at any one time. What stimulates this infrequent cell division is unclear. However, cytokines, such as those produced either constitutively or during the course of antigen-specific immune responses directed at non-cross-reactive antigens, could be responsible. One such cytokine, interleukin-15, has been implicated in maintaining CD8 memory T cells. Regardless of cell division, the number of memory cells for a given antigen is highly regulated, remaining practically constant during the memory phase. And that's immunological memory is long-lived after infection or vaccination. Have a great day.